With growing industrialization and vehicle density, air pollution has become a serious problem around the globe. When laws were introduced in Western industrialized countries in the late 1960s to limit the pollutant emissions of motor vehicles, the number of mechanical and electrical emission control components in vehicles began to rapidly increase. This in turn made it more difficult to carry out error diagnosis in repair shops. As a result, the first basic diagnostic systems were introduced to provide assistance in the repair shops. In Volkswagen Beetles with the model year from 1972 onwards, it was possible to use program cards to carry out a semi-automated error diagnosis. In 1988, onboard diagnostics, or OBD for short, were introduced for the first time as a legal requirement in California in order to monitor the function of the emission control systems and components. This involved a simple diagnostic system integrated in the vehicle that recorded, stored and displayed errors in exhaust-related components. A year later, this OBD1 became applicable for the entire USA. The OBD2, with its wider range of diagnostics, has been in effect in the USA for passenger cars and light utility vehicles since 1996. In 2000, the European Onboard Diagnostics (EOBD) system was introduced in Europe for passenger cars and light utility vehicles with petrol engines, together with the Euro 3 emission standard. Since 2003, the EOBD has also been applicable for passenger cars and light utility vehicles with diesel engines. Since 2006, the EOBD has applied to all utility vehicles. In some respects, the requirements of the EOBD are a little less stringent than the OBD2 used in the USA. In order to compete at a global level, many vehicle manufacturers outside the USA therefore conform to the more stringent OBD2 used there. If a fault occurs that compromises the exhaust gas quality, a standardized diagnostic trouble code is stored in the fault code memory of the engine control unit. The operating data and environmental conditions at the time the fault occurred are also stored, the so-called freeze frame data. If an exhaust gas-related fault occurs, or if a fault is detected during self-testing of the control unit, the OBD fault lamp lights up continuously. If a fault occurs that leads to cylinder shutoff or to damage of the catalytic converter, the OBD lamp flashes. Depending on the severity of the fault, limp home programs may be activated to protect the engine. If a fault does not recur after a certain time period, the OBD lamp may go out. However, the corresponding error message remains stored in the memory. Faults and stored data can be displayed on a scan tool via the diagnostic socket. The connection and data transfer are standardized. This means that the plug assignment and transfer protocol is the same in all vehicles. The diagnostic trouble code specifies the component in question and the type of fault. The wording of the text used for a display diagnostic trouble code may vary depending on the scan tool manufacturer. The stored diagnostic trouble codes and operating data are important in aiding diagnostics and rectifying the fault. For more information, contact your local motor service partner directly or visit the web addresses shown.